So I decided to make a notebook and explore this stock, the Pure Hydrogen Corporation Limited, and I found really awesome information. Okay, so this stock is based in Australia, and it focuses on providing a awesome solution for hydrogen and clean energy. It's looking to produce hydrogen plants all across Australia. And the advantage of hydrogen is that it's fast recharged, long range, weight loss, zero emission, and cleaner burn. So let's import these packages to the environment. So I did import it before. I did this before because I trained the neural network, which I'm going to show you later. So then we'll go ahead and fetch the data, which the symbol is PH2.AX. AX stands for Australia dataset because it's an Australian company, and for the past 5-year period. And we'll go ahead and put that in our environment. And so looking at the first 10 rows, we can see over here we've got some columns, open, high, low, close, volume, dividends and stock splits, and the dates. And 7 columns and 1,267 data points. I went ahead and dropped the NA and plotted the data. Right now we can just see the volume is quite high, especially in this area and this area as well. Let's explore the data. So we're going to import stock status. So first we're going to look at the simple moving average and exponential moving average. Simple moving average pretty much just means the average mean of a data points. So you add up all to the days divided by the days, which gives you how much the share cost for the price for that day. The average for that day, average price. And then we move on to, here we go, so this is the SMA and close, so we can see it's sitting just around here, so that's how much simple moving average is, just moving around this area here. And then we will look at the EMA, which is the red one. Again, it's just around here as well, exponential moving average. And then we're going to look at the relative strength index. So this is to visualize the relativity of strength of the index. So looking at the stock, at whether it's overbought or oversold. And if it's above 70%, it means that it's overbought. And if it's below 30%, it means it's oversold. So this tells us whether this stock is bearish or bullish. So let's go ahead and just explore the EMA for 10 days. Again, it's going quite a bit up. Then we look at the moving average convergence. So this is the trend momentum, which is like 2 lines, and whenever they cross, it tells you whether it's going to go up or it's going to go down, or which trend is going. And so, yeah, again, it's just around here. So let's process the data. We're going to split it into X train, Y test, X train. And we are mainly going to be working with just a closed column and using min-max scalar from -1 to 1 to transform the data. And this is what it does. So now we only have just a column, and you can see over here that it's either -1 or 1. So now we're going to create a function that can load the data and look at 60 days back. So it can also split the data. So this is what it does here. And this is the shapes. So this, you can see the 3-dimensional and then 2-dimensional shape. We're going to turn it into tensor, a language that is just pretty much a bunch of numbers that the computer understands and the machine learning understands. Again, so we're going to go ahead and build our model. So this is the function of the model. but the most important bit is just the input dimensions and the output dimensions. And in between that, there's hidden layers as well. So there's 64 hidden layers and 64 dimensions, sorry, and 2 layers in there with a 64 dimensional array, so that it can process all the information. So that's the model built here. So we're going to go ahead and train the model. So I've trained it before with 300 steps. And we'll go ahead and look at the training loss, so how fast it learned. It learned like so, and yeah, so it learned pretty quick starting from there. And we're going to go ahead and make a prediction. So our prediction right now shows on the train scored on 0.04 RMSE. That's a mathematical equation that pretty much tells us how good is the performance of this model. So if it's between 0.2 and 0.5, then it's a good model. And then, so we're going to go ahead again, visualize it. And we're going to use a linear regression this time as well. And this time we want to forecast our data set and see how far into the future, say 2 weeks from now, how much it's going to be. So this is our data again, 7 columns with 1,267 data points. And I took the open, high, low, and close. And this is a graph of it, visualization. Then I went ahead and split the data, and I'm using sklearn package, which has a linear models that we can create from it. So this is just a function that defines how we're going to prepare that data and then feed it to the model. And we're looking at 5-day focus. So X train, Y train, and prepare it, and then divides it to X train, Y train. And with the linear regression, we went ahead and trained it with the X train and Y train, and it brought a score of 0.93% accuracy, and forecasts to be somewhere around here, which is pretty cool. So it's bound to be going up from here. But what would be quite cool as well is to find out when is the perfect time in terms of here. So even wait for it to be around 60 or 40. That would be the perfect time to get in, and then it will just go up from there. Yeah, enjoy guys.